All right. All right. So we uh we continue with modeling real world objects. So modeling real world objects is the range of an electric car a property of the battery or of the car? Bro, I don't even know what a range is, but I'm about to find out. Honestly, I don't know this stuff. What's a range? How far the car can drive on a full battery before it needs to recharge. So your phone battery lasts a certain number of hours. An electric car battery lasts a certain number of miles. So if an electric car has a range of 300 miles, that means it can usually drive about 300 miles on a full charge before the battery runs out. So does the range depend on the battery? The bigger the battery, the more the range, or the car itself, as in weight, aerodynamics, efficiency. These things also affect range. For example, two cars with the same battery might have different ranges because one uses energy more efficiently. So does that. As you begin to model more you'll is the range of an electric car a property of the battery or of the car itself? If we're only describing one car, it's probably fine to maintain the association of the method get range with the battery class. But if we're describing the manufacturer's entire line of cars, we probably want to move to get range to the electric car class. The get range method would still check the battery size before determining the range, but it will report a range specific to the kind of car it's associated with. Alternatively, we could maintain the association of the get range method with the battery, but pass it a parameter such as car model. The get range method would then report a range. Okay. All right. I just want to have GPT rewrite this paragraph for me, and I wanted to like do like a music metaphor so I can get it better. Yeah, it's about where behavior belongs in the program. I get that. As your programs become more detailed, you have to decide which class should be responsible for certain behaviors. For example, Should an electric car's range be determined if you're only modeling one car? It means it's calculate the range. But if you're modeling many different car models, range may depend on more than just battery size. In that case, the electric car class might be a better place. Okay, music theory example. So you're building a music app, right? You got a scale class and a song class. Where should the method get notes belong? If you're only concerned with scales, it makes sense for scale get notes to return the notes C major, G minor. But suppose you want to know which notes are actually used in a specific song. Two songs in C major might use very different notes. And the behavior belongs more naturally to the song class, right? So you do song get notes instead of scale get notes because the answer depends on the song, not just the scale. Electric car example is the same idea. If range depends only on battery size, put get range in battery. If range depends on the whole car model, put get range in electric car. The real lesson isn't about batteries. It's about deciding which object owns a piece of behavior. Yeah, okay. I think I have belabored this paragraph enough. Moving on. All right, so let's get to the exercises. We got four here. Ice cream stand. So this is you know what's funny? The word bionic used to be like really popular. It's kind of fallen out of favor. Like people used to do it all the time, like the bionic woman and stuff like that, right? What happened to that word? Am I going to waste my time going on a GPT hole? Yes, I am. Hey, real quick, I noticed that the word bionic used to be really popular. You had like the bionic woman, right? Or somebody was like really good at something. Like you were really good at like I don't know playing sports or something like throwing hoops. Like you got bionic arms, but nobody really uses the word bionic anymore. It sounds almost dated in a way. It's kind of like back in the day when people were into technology, right? Like in the 70s, they'd be like he's into electronics. When today we'd be like he's into computers, right? What happened to the word bionic? Why did it fall out of favor? Yes, this is the kind of shit I asked ChatGPT because I got to know real quick. Futuristic term that got overtaken by reality. Originally, bionic came from a blend of biology. Yeah, okay. It referred to the idea of engineering systems inspired by living organisms. Then popular culture grabbed hold of it, especially through the TV show. Oh, the Bionic Woman was a TV show. Okay. In the 70s and 80s, bionic became a buzzword. People used it semi jokingly. It carried a sense of science fiction wonder. The technology didn't actually exist. But several things happened afterward. The future arrived more slowly than expected. Instead of people running around with superhuman robotic limbs, we got increasingly specialized technologies, prosthetics, implants, pacemakers. Engineers and doctors preferred precise terms over the casual bionic. Science fiction flavor became dated. Bionic sounds very 1970s in the same way that space age sounds very 1960s. That's true. It evokes like chrome, analog electronics, and the new buzzwords replaced it, like computers, cyberspace, digital, biotech, AI, machine learning, right? A company pitching a robotic arm today is more likely to call it an AI powered prosthetic than a bionic arm. It sounds almost funny. Like they're introducing a superhero, right? The extraordinary became ordinary. When something is new, it gets a flashy label. Once it becomes normal, people use more specific language. Nobody calls a pacemaker bionic technology anymore, which it kind of is, right? It's just a pacemaker. Interestingly, bionic hasn't completely disappeared. You still see terms like bionic eye, bionic prosthesis, but these uses tend to be technical or marketing oriented, right? The comparison with electronics is pretty close. In the 70s, electronics was the exciting technology category. Today, it's so broad and commonplace that people talk about software, AI, smartphones, robotics, or computers. Likewise, bionic was once the catch-all word for the amazing technological future of humans. All right. Okay. All right. An ice cream stand is a specific kind of restaurant. Write a class called ice cream stand that inherits from the restaurant class you wrote in exercise 9.1 or 9.4. Either version of the class will work. Just pick the one you like better. Um, Add an attribute called flavors that stores a list of ice cream flavors. Write a method that displays these flavors. All right. 9.1, 9.4. So 9.1 we had this. 9.4 we just had the increments and the people, stuff people serve, right? So let's grab this one. Inherits from the restaurant class you wrote in exercise 9.1. So we're going to have a class here called ice cream stand, and because it inherits, here we put restaurant. Now, if I remember correctly, Add an attribute called flavors that stores a list of ice cream flavors. Um, and then we had, what was it? Was it this? Was it this? Chocolate ice cream. Strictly chocolate ice cream. That's all we are going to serve. Is this gonna... Ew, that's not good at all. Takes three positional arguments. Self-named cuisine type, so we've missed... Okay, let's look. Battery instance as an attribute. So we got class, right? Battery. The init method for a child class. That will only have to write code for the attributes and behavior specific to electric cars. So we got electric car. That was the original car class, right? We had some functions, methods rather, and then class electric car, right? Then def init self make model year. Super. Oh, okay. Now, I want to pause for a second because I want... Okay, I just want to go here real quick. Just want to see. Right? Okay, yeah, we don't see self being passed to super. Why isn't it super? Right. Because super handles that for us. Conceptually, Python is doing something like restaurant dot in itself name cuisine type behind the scenes. So in itself, it still needs self because you're defining an instance method. But super doesn't need self explicitly because super automatically knows which object is being initialized. The question says add an attribute called flavors. That stores a list of ice cream flavors. Looking at your current ice cream stand class, where is the flavors attribute being created? I don't see it yet. That's the okay, bro. Okay, bro. Relax. GPT, like that's the next thing I'll focus on before worrying about the inheritance syntax. All right, there, buddy. All right, bro, cool. Where's the flavors attribute being created? Yeah, it's going to be created. It just exactly, exactly here. Stores a list of ice cream flavors. Stores a list. Okay, I said it was only chocolate, but it's fine, whatever. Write a method that displays these flavors. And call this method. Am I going to call it? Yes, I am. Oh, yeah, yeah. You happy now, motherfucker? What else you got? What you got to say now? Inheritance, super init. One thing to notice creates a new attribute that exists only on ice cream stand objects. Meanwhile, self-named cuisine type were created by the parent class, but the parent class is in it. Yeah. So after this line, my ice cream, your object contains name. Yes, I know that. Some of those came from the parents, not from the child, but from the object's perspective, they're all just attributes. One thing I'd like you to think about right now, every ice cream stand in existence will have exactly these three flavors. If tomorrow you wanted Seb's ice cream, vanilla chocolate, Mike's ice cream, mint cookie to rocky road, would flavors belong hard coded inside int? Or should it be supplied when creating the object? Don't change your code yet. Just think through that design question. Okay. If a value, the deeper principle is if a value can vary from object to object, it is often a good candidate for an instance attribute initialized by a parameter. We're starting to think in terms of modeling data now rather than just writing procedures. That's the important shift in chapter 9. All right, cool. Great. So we got that. Yes. All right. Let's go to okay. An administrator is a special kind of write a class called admin that inherits from the user class you wrote in 9.3 or 9.5. Add an attribute privileges that stores a list of strings like can add post, can delete post. Write a method called show privileges that lists the administrative set of privileges, and then create an instance. Yeah, okay. I mean, I don't even need this stuff. I'm just going to get rid of this stuff for brevity. Add an attribute privileges that stores a list of strings. Can delete post. Write a method called show privileges that lists the administrative set of privileges. Wait a minute. Is a special kind of user. Write a class called admin. Oops. Yeah, I kind of forgot about that. The users don't have these things. The whole point is that we create a class called admin, right? Passive user. And then we got special. What are we missing here again? Super, not special. They don't have to be identical. So restaurant name. The parent only needs a name. The child might need more. Name, flavors. Okay. This is stuff that okay, need to go over again, but cool. So, and then here, hmm you have following, the following, right? You have the following privileges. Ooh, crazy. One thing worth noticing, class admin user means an admin object has all the attributes of a user plus whatever additional stuff you gave it. So your admin one object has all this stuff plus privileges, even though you only explicitly created privileges in admin. Right. A question to think about. Right now, every admin automatically gets these privileges. What would happen if your site later had moderators, junior admins, super admins, and each had different privileges? You're about to encounter a common design choice. You can have privileges inside the class, like I just did here, or pass privileges in it, right? The same design question you just noticed with the ice cream flavors appears again here. All right. Okay. Good. Second here. Uno minuto, por favor. All right. Next. All right. Write a separate privileges class. So one attribute privileges that stores a list of strings as described. 9.7. Move the show privileges method to this class and create a new instance. Okay. Write a separate privileges class. The class should have one attribute, privileges. It stores a list of strings as described. Yeah, okay. Move the show privileges method. Why would I do that though? Move the show privileges method. Make a privileges instance as an attribute. Make a privileges instance. Okay, I gotta look at the instances as attributes. Oh, Growing list of attributes and methods that your files are becoming lengthy. In these situations, you might recognize part of one class can be written as a separate class. This approach is called composition. All right, quick question though. Is this thing a type of the parent, or okay, or is it something the parent has? Got it. Use a child class where we can honestly say an X is a Y, like an admin is a user, right? A guitar is an instrument. An electric car is a car. Those are special versions of the parent. So inheritance makes sense. Composition, separate class as an attribute, is when you can honestly say an X has a Y. A house has an address. A student has a transcript. Okay. So going back to this, write a separate privileges class. It should have one attribute, privileges, that stores a list of strings as described in chapter. And move the show privileges to this class. Make a privileges instance as an attribute in the admin class. Create a new instance of admin should have one attribute, privileges, right? One attribute, privileges. Okay. And then we take this. So if I want to show um, admin one, this one is an instance of admin. There we go. That's because that's why. What else we got? 9, 9. Use the final version of electric car. Um, yeah, where's that? How am I going to use the final version of it? Okay. Add a method to the battery class called upgrade battery. Does what? Checks the battery size and set the capacity to 65 if it isn't already. Wait, what? Okay. Make an electric car with a default. And this was in here. All right. And then this thing says, make an electric car with a default battery size. Call get range once. So default. Bro, I don't even know. It's just Tesla? I have no idea. 2024. Whatever. So this is going to take the default battery size of 40 through here. And, right. So if I do battery and then battery size, we get 40. Nope. Okay, okay, bro. I got it. I got it. All right, yeah. Um, All right, there's a lot of thinking for something very simple. Call get range once, and then call get range a second time after upgrading the battery. You should see an increase in the car's range. Okay, cool. So my electric car, right? Get range is inside battery, which is an attribute inside electric car. So that's battery and get range. Battery object has no attribute get range. You kidding me? Oh, bro. But get range already prints. This car can go about 150 miles on a full charge. Now, if we upgrade to from 40 to 65, then we should get this car can go about 225 on a full charge. So let's upgrade. And there it is. All right, are we done here? See an increase in the car's range. That's exactly what we got. Great. That was exercise 9999. Boom. Then we got importing classes. Standard library. All right, so two more sections in there. So I'm gonna. All right, here's what I'm gonna do. I'm gonna read this, like skim this real quick. Paying as much as attention as I can without reading too closely. Then I'm gonna come back to it tomorrow. So this will be kind of like a mental primer. All right, let's go. As you add more functionality, inheritance and composition properly. In keeping with, you want to keep your files as uncluttered as possible. To help Python let you store classes and modules, you need classes in modules, and then import the classes you need into your importing a single class. Let's create a module. We already have a file named car.py in this chapter. Well, you do, buddy. But this module should be named car.py because it contains code representing a car. Okay. Okay, read odometer, update odometer. Okay. We include a module level docstring that describes the contents of this module. Yeah, okay. You show the docstring for each module you create. So, mycar.py from car import car, and we got my new car. So it's just like when we were importing functions, right? Um, then we got my new car. Okay, my new car. Okay, we call in the methods. Okay, got it. Importing classes in an effective way. Picture how long this program file will be. All right, yes. When you instead move the class, okay? So you take the class, you put it in a separate file so it doesn't take up space. Then you import it and use it like normal. Storing multiple classes in a module, although each class in a module should be related somehow. Battery and electric car both help represent the car, so let's add them to the module car.py. So you got class car, then the battery with its methods describe battery and get range. Electric car. Yep. Importing multiple classes from a module, so just import car, comma, space, electric car. Okay, easy enough. Importing an entire module. You can also import an entire module, then access the classes you need using dot notation. Okay, yeah, we got the dot method, the asterisk, the wildcard, just like with the methods, the functions, but not recommended. Importing a module into a module. A class in one module depends on a class in another. When this happens, you can import the required class into the first module. For example, let's store the car class in one module and the electric and battery classes in a separate module. We'll make a new module called electric car and copy just the battery and electric car classes into this file. Battery and electric car are in there, and this one is importing car. Right? So car is a required class, right, for electric car because it needs to access the parent car. So we import car directly into the module. And if we forget that, Python will raise an error. We try to import the electric car module. We also need to update the car module so it contains only the car class. Yeah, okay. Now we can import from each module separately and create whatever. We got aliases. Electric car, import electric car as EC. Okay, yeah, right. Right. As you see, Python gives you many options. It's important to know so you can determine the best ways when you're starting out. Keep your code structure simple and move your class around once everything is working. If you like how modules and files interact, try storing your classes and modules when you start a project from them. Okay. All right, and then we have these three exercises here: import a restaurant, imported admin. Okay, this is easy enough, but for now, I'm going to call it a day, and we'll continue next time.